So thanks, Shireen, for the intro. But also thanks everyone for joining the workshop today. Before we get into it, I think it's important to understand a little bit more about why we're here, a little bit more about HashiCorp and who we are. A lot of the time at HashiCorp, we hear customers tell us a few main things, right? They tell us they're moving to the cloud, maybe not one, but several, right? They need some sort of application modernization, or they've got some sort of strategy around that. And they want to be DC free, right? They're looking to move out of physical hosted data centers and move into some sort of cloud or infrastructure as a service, platform as a service. And they want to do this by such and such a date. And so what we help these same customers do is safely move their application using cloud infrastructure automation tooling. And our software stack enables these customers to provision, secure, connect, and deploy their app into any infrastructure in any cloud. So a lot of people might know us as HashiCorp, but maybe they know us about our tools, right? We certainly have startup roots. People might have heard about Vagrant or Terraform, but we're not that company anymore, right? We're well-funded, we're staffed to deliver innovation, and we're growing rapidly. And so in the last 8 years or so, we've added a lot of enterprise customers, right? We have over 1,000 customers using our enterprise tooling. Of that, there's 7 that make up the Fortune 10, and of that, 8 make up the top 10 global financial companies. And the thing that all these companies have in common is that they're going through a shift in how they operate, right? A generational shift that's taking that model of a traditional data center where you might typically have on-premises hosted infrastructure and migrating selected workloads into the cloud or into a cloud operating model. And most businesses are choosing to refactor those systems of engagement. The customer-facing app, right? They might rebuild them from scratch using this cloud model. Why? Well, they want customers, right? They want to attract more people. They want to interact with those people in new ways. And they want to meet these people or customers where they are, right? So they need to transform for this digital world. Having said that, it's not straightforward, right? You can't just lift and shift everything and migrate to the cloud and hope that people will come. And so what we typically see is that for some systems, maybe like a database or system of record, that might remain in an on-premise environment. And therefore, what we see massively is most customers end up having, or without even realizing it, having a multi-cloud strategy. And so while there are great benefits with this cloud adoption, there's also some fundamental challenges and concerns, right? Especially as a lot of these same organizations push for greater efficiency, increased consistency, application delivery. There are a lot of challenges in that space. But ultimately, the reason for the shift to cloud is to accelerate that application delivery process, right? But as we adopt this new cloud operating model, we're introduced to new tooling, new ways of working, right? There is additional complexity. If we took a quick glance at the cloud landscape, we can see how different the model is, right? As an example, if I look at that, second to bottom line, secure, it's like, how do I do security in the cloud? Well, AWS has their own way. They've got AWS IAM. Azure has their own way with Active Directory. GCP has their own way. If you're in an on-premises data center, then you've probably got a way. And so what we see then, if we take any of these kind of pillars, is the challenge for any enterprise ops and security team is, how do they reconcile this reality? And so what a lot of companies are trying to do is establish a centralized shared service platform with a single control plane. And at HashiCorp, that's what we're doing with our tooling. But don't just take my word for it. We've got some customer case studies. Here's one of them, right? A large telco customer. They averaged about 22 weeks. I think it was over 70 steps before any application saw traffic, right? This is really the opposite of what we're trying to achieve with this digital transformation and DevOps. And so by using our solutions, they're able to drop the number of steps required down to 1, and applications were deployed typically in less than 5 minutes. We also have a number of other public case studies, right? If I look at in the Terraform pillar, Cruise, who are an automated car company. One of the key takeaways from their story is that they were able to leverage Terraform Enterprise to increase engineering agility, rapidly build their autonomous vehicle technology, right? It helped them increase their productivity, right? They reduced a lot of risk. So they used our policy as code framework to build out modules for governance, compliance, etc. And then they increased their agility, right? They had standardized patterns to be able to consume the cloud. In the Vault sector, Adobe is one of our most prominent public-facing customer references. Right? If you've used any of the Adobe Suite outside of their creative tooling, you might have consumed this as part of some sort of SaaS platform. Right? They have thousands of customers who use this every day, and Vault is central to that whole process. Anytime someone touches them, it kind of passes through Vault for Vault's encryption. And so Adobe do something like 800 million transactions per month with Vault, right? The key takeaways from this case study is, they increase their productivity and security posture. They reduce their risk, right? All their user data and information is protected and stored safely by Vault. And they increase efficiency, right? They have many Vault clusters globally. They replicate between them. And then the cost to manage is drastically lower. In the console space, Mercedes-Benz have talked publicly about how they use console's service networking to accelerate their application delivery. They started early on with console to do service discovery, service registry, and are now adopting console for a service mesh, right, across multiple Kubernetes clusters. And finally, Roblox. Anyone with children, maybe during COVID, probably heard about Roblox. They are a well-known gaming platform. I think pre-COVID, they were doing something like 100 million players across their platform. All of that is served by Nomad, right? Nomad enables Roblox to scale their global gaming platform. If you did use it during COVID, you'll probably know that I think those numbers roughly doubled, right, in terms of those number of players. And all of that was done seamlessly with Nomad, right? It's operationally simple. They talk publicly about, very few people are required to manage this infrastructure. It's flexible in the sense that it can also, schedule not just containers, but, non-containerized workloads. And improve their productivity now because they could get their apps out into the market a lot quicker. And so as the implications, right, of the cloud operating model impact teams, across infrastructure, maybe security, networking, maybe across that application tier, we see these repeating patterns, right? Enterprises are looking to stand up these centralized shared services, right, or a center of excellence to deliver some sort of dynamic infrastructure, right? And as teams deliver on each of these shared services, they become more mature in their cloud operating model, right? They become faster, they gain increased velocity, right? And so I'm going to hand over now to Moayad, who's going to run the rest of the workshop. Over to you, Moayad.
Thank you, Cam. Bear with me a sec while I just switch to my screen. Can everyone see my screen okay? Just confirming.
Yep, got that. Yep.
Fantastic. Well, thank you, everyone. Welcome to today's workshop. My name is Moayad Ismail. I'm a senior solutions engineer. I am based in Singapore. So I'll be taking you through the workshop today. There is quite a lot to cover, but I'm sure we'll get through it. And yeah, so the intent of this workshop is to introduce everyone here to the Vault OSS open source version of Vault. However, I will make references to specific features that are available in the enterprise version of it. And it's really aimed at giving you insight to how Vault operates, what problems it solves, and gives you some idea of how you can potentially use a tool such as Vault in your environment. I trust that a link has been provided with the slides so you can follow along. So yeah, please feel free to do so. I wish I could go through everybody, you know, and get to know you a little bit better with the introductions, but there are quite a few of us on the call. So please feel free to reach out to us afterwards if you wish to discuss about anything relevant to today's session. We will be covering quite a few things. So we will touch on the Provider Vault overview. Then we'll go into 6 key areas. How do we interact with Vault? How do we run it as a production server? What are the Vault secret engines and what they do and what options you have there? And also we'll be discussing the Vault authentication methods and very importantly, also Vault policies and how they work. Also, we'll be getting hands-on, putting into exercise the information that we will go through shortly. And also we'll be covering how do we use the dynamic database secret engine in one of the labs as an example, and also encryption as a service. So Instruct is our platform for the hands-on labs. You would have been provided a invite link for you to get access to those labs. They are split into 3 tracks: the Vaultbasics, Vault Dynamic Database Credentials, and the Vault Encryption as a Service. If you have any trouble with reaching those, please feel free to post in the chat, and my teammates will help. So let's get started with the overview. Now, Vault is a security tool that allows for API-driven secrets management across, and it is cloud agnostic. You can deploy it in private clouds, in your legacy data centers, in multi-cloud. It allows you to store different types of secrets, right? And what is the secret? Secret is basically any sensitive data you wish to protect and make accessible to only authorized, clients, users. And the ability to do that is becoming a lot more important these days, and we'll go through that shortly. Also, Vault allows you to generate dynamic short-lived credentials. So just-in-time credentials for target systems that you need access to that are rotated, retired, and well maintained. So we'll get to go through that also, some examples. Before we get started, I mean, let's take a step back and kind of discuss the traditional security model we're all very familiar with, right? It's also known as the castle and moat method, where you build a hardened shell around your data center or your critical environments, and you have like an internal zoning architecture, and you can separate using firewalls, VLANs, and so on. And pretty much it's built upon the idea of like a perimeter-based security. And you establish DMZs and so on. And the firewalls would protect, kind of segmenting a network from another network. Now, these are pure, like based on static IP addresses, typically, and static infrastructure. So once you allocate an IP address to a resource, it rarely changes. And if it does, it results in configuration changes on the firewall, which could take quite a bit of time. And with the introduction of, so why is this a bit of a challenge today? Simply because of the new platforms that are being introduced, right? We've got, container workloads, Kubernetes, orchestrators. We've got, things like OpenShift and hybrid clouds. All of a sudden, these security models are no longer sufficient, and we have to find other ways of protecting our critical data and assets. Also, we see this quite a lot, where we end up hard coding credentials in our scripts, in our application configuration files. We share service accounts. We don't know who's using them after a while. Are they still effective or not? When were they last rotated? And if we were to decommission them for whatever reason, right, they could cause a service impact, right? And this is where other like modern security measures are starting to come into play, and they are based around identity. So now that we don't have not as well defined perimeters, you are extending into less secure or less trusted networks. The changing into a identity enforcement is becoming the norm today, and that's being well displayed by, for example, the cloud providers with their IAM access. Everything is managed via IAM, right? All access. And the idea is how do we enable identity enforcement? And this is where Vault really kind of comes in. And as you can see here, Vault uses identity-based security where clients, and what I mean by clients here, it could be a VM, a physical machine, an application, a serverless function, anything that requires access to a secret. And we'll describe further like the secrets at a later stage. For example, like an SSH key or a PKI certificate. They must authenticate themselves against an identity provider that you trust, and such as LDAP, Okta, Active Directory, the cloud provider IAM, right? You have many different options. And once the authentication is done, Vault is then, based on the policy that's been set for authorization, it will allow the client to retrieve the secret that it needs for it to connect to the target system. And you will see some of those examples in the labs. So the advantages of the identity-based security are numerous. One, it allows you to stretch the security across network perimeters. You're no longer tied to, okay, like for my on-prem, it's closed, nothing can get in and out. You're able to stretch the security across various boundaries now. You're able to provide dynamic short-lived credentials that are rotated frequently, right? And you have full control of the life cycle of that secret. Individual accounts maintain provenance. And what that means is you're always able to tie back to an identity. Who requested this secret? When? Why? Right? And then do they have the right policy in place? And also, we can invalidate the credentials quite easily. So we can revoke them. So if you have a security incident and you need to respond, you have the ability to revoke very quickly. One of the key concepts is the Vault Secret Engine. Now, the Vault Secret Engine, secret engines are pluggable components that allow you to interact with secrets. We will expand on that shortly. Just wanted to cover the high-level architecture of Vault, the internals. Just wanted to highlight one thing. So there's the Vault Core, and the Vault Core, because it's a pluggable system, as you can see, the secret engines, you can create your own secret engines, right? And there's a lot of examples, and we have in our Learn guides how you can create your own secret engine that will interact with your internal systems. Authentication methods are also pluggable. So as you can see, it's a very pluggable architecture. And the concept here of the barrier where anything coming into Vault or accessing Vault must be encrypted in flight. So you can use certificates to terminate HTTPS traffic into Vault, and anything that leaves Vault into the storage backend is also encrypted by the Vault barrier, right? So the security is obviously of utmost importance of protecting the data, and this is kind of just a high-level view. If you wish to know more, there's a link that you can click and visit our documentation. Vault plays a critical role in a lot of organizations today, as Cam mentioned, especially like in the financial sectors also. So availability is a key requirement, and Vault is architected to be highly available. We can have standby servers that can, kind of step in when there's a failure in the primary. And in the enterprise version, it allows you to even scale out more, where you can deploy multi-region, where you have a single control plane from a central vault that you're able to control, replicate secrets across different regions. So, and this is part of our enterprise offering, but it allows you to scale operations of Vault, in unlimited, really. So as an overview, Vault is a secret management system. It is API driven, very developer friendly. It allows you to extend into untrusted networks. It supports dynamic generation for short-lived secrets, and it's built for high availability. So how do we interact with Vault? So Vault, there are three ways of interacting with it: by the CLI, the UI, or the API. And the Vault application itself, it's written in Go. It's a single binary, and the Vault CLI actually, you can it's lightweight. You can deploy it across all the different platforms, Mac OS, Windows, and Linux. And if you search Vault downloads, you can in Google, you can find out the latest version and download it into your machine. It's very easy to set up and test. All you need to do is unpack the Vault binary, put it into your path, and then, yeah, you're able to interact with Vault. There are some basic CLI commands. I will not cover them here because in the lab, this is where you get hands-on and you get to go through all the commands. So I'm going to skip through any of the commands. I'm not going to bore you with that at the moment. But you can read and write into the secret engines and so on. This is really important to know. So the Vault server modes, it can operate in two modes. One is in dev mode and the other one's in production mode. Now, dev mode is intended purely for development, where you download it locally on your machine, you're doing some testing, you're proving out, testing the API and so on. Production, obviously for QA and production environments. Now, in dev mode, it is not secure, all right? It's set up to just be stood up really quickly for you to test the APIs and some of the features, right? It stores everything in memory. So if you shut it down, you lose all the data in there. So please do not, if you ever think about deploying Vault, do not deploy it in dev mode, because any secrets written into it, if you have a reboot of that server, you lose your data. It is automatically unsealed, and we'll talk about the sealing, unsealing process shortly. And you get a root token you can specify, which is kind of like the root password. You can specify upon launching it. So as you can see, you would never run this in a production environment. The Vault UI, pretty straightforward. You always need to be able to authenticate to the Vault UI. You get given a root token to begin with, and that token is what you use to first interact with the Vault UI. You will experiment with the Vault UI in the labs, so I won't expand on it too much further here. This is what it looks like just from the front end if you have not seen it before. You get like a tour when you log in. You're able to get started. There's some guides. Yeah, so it's quite intuitive. You can follow along. The Vault API by default operates on port 8200, right? And this endpoint does not require authentication. So I'll show you the example output of this, and you can use JQ to beautify the JSON output, but this is what it looks like. You actually get like details on the Vault. Is it sealed? Is it standby or active? What the version it's running, has it been initialized, and so on. So you can, this is just an example of an output for a Vault API. So some of the endpoints do not require authentication. There's not many of them actually, but most do require authentication. And the way you do that is you set a header of X Vault token with the token, and then you're able to authenticate and use the API. So we've covered the three ways of interacting with Vault, and you will go through each one of those in the lab. So the CLI, the UI, and the API. And we spoke about the two server modes, dev and prod. Cool. So let's talk quickly through how to set up a production Vault server. And you will set one up in the lab, but just giving you kind of some insights. You need to specify a configuration file when you're bringing up a Vault server in production mode. And this config file in the next slide will cover, what are some of the components. But once you've built your config file, then you start the server, and then you need to go through an initialize process. So you initialize the server. Once you initialize it, you get unseal keys, and you get an initial root token. This is really a very important step in getting Vault ready for business, right? To start accepting traffic. So, and then once you've initialized it, you then have to unseal the Vault server with the unseal keys you get given as part of the initialization. And you will go through that process in the lab. So the configuration, some of the things that you'll need to configure is the listeners. You want to listen on all ports, or you want to change the default port. It's up to you. The storage backend that's in use, the log levels, these are well described in the documentation. I won't cover them here, but as you can see, there's quite a few configurations you can put together to suit your production environment. To start the production server, it's quite straightforward. You do a Vault server, and then you reference the config file in the process, and then do not use the dev option. If you use the dev option, obviously it will launch it in dev mode. You will get to launch a dev mode Vault server and a production server in the lab. Now, initializing the Vault cluster, I just want to expand on that a little bit. The Vault initialization must be done on every Vault server. So if you have a Vault cluster that comprises of 3 nodes, you must initialize each one, right? And so they can all participate as part of the cluster. You only need to do that once. And the command you use is the Vault operate init command. And this is something important to note. You can actually set the key shares and the key threshold. We use Shamir key algorithm where we split the decryption encryption key that Vault needs for the unseal into 3 keys or 5 keys. You can specify that. And the idea there is you don't give 1 key to 1 person to unseal. You can split it up for the additional security. They all need to come together for the unseal process to be successful. All right. So that's something important to note. Once the initialization is done, you can then proceed with the unseal command, and you go through the keys, the shared keys. You specify based on the threshold you've set. You punch them through, and then you've unsealed the Vault cluster, and then it becomes active. Once that's all done, if you want to determine what the status of the Vault server is, you run a Vault status command, and that will tell you that it's in HA mode, like how many key shares it's set up for, if it's in a performance standby, what version of Vault you're running. So there's a lot of useful information that you do get from running a Vault status. All these commands we've covered, you'll run through in the lab with them. So no problem there. Just want to make sure that for production mode, you need to have that configuration file. You must initialize the Vault cluster first. Once done, you proceed with the unseal. Once the unseal is done successfully, Vault is able to serve, basically clients after that point. Cool. We've covered a lot of ground so far. Bear with me. There's another 2 chapters that we'll cover that are quite important. And then I'm sure everybody's keen to get their hands dirty on the labs. So we'll get there very soon. The Vault secret engine is a critical component in Vault, which allows you to do one of 3 things. It allows you to store static secrets in the form of like key value with versioning. For example, credentials, usernames, passwords, tokens, right? Things you want to store in the KV, that's possible. You can also generate dynamic secrets against different types of infrastructure and cloud providers. For example, databases, we support things like Oracle, Postgres, MySQL. You can generate dynamic credentials against those types of databases. We also support against cloud credentials, like you can generate temporary API keys in AWS, Google, Azure, so on and so on. You can manage service accounts, rotation of service account passwords. So there's a lot you can do from a dynamic, from the dynamic secrets perspective. And lastly, we also support Transit. Now, Transit is our secret engine that does encryption as a service, which allows applications to offload a lot of their encryption requirements and not having to manage all of the libraries, encryption libraries, off to Vault. Vault will do the encryption, pass back the ciphertext. We also support tokenization, but that's in the enterprise version of Vault. So encryption or data protection is a key feature in terms of secret engines that Vault provides. Here's another list, but what we see that are important a lot to our customers, these are the secret engines we see in heavy use. So key value stores with versioning, PKI certificates, SSH key signing, databases, cloud credentials, Active Directory, and the encryption as a service. And there's obviously a lot, many others, but these are the ones that are used quite often. So how do we go about enabling secret engines? Quite straightforward. The Vault secrets enable command allows you to, here's an example, allows you to mount a secret engine. So we say, this is the type of secret engine. It's of type AWS. And as you can see, you have the option of setting a path. This is really important because what you could do, if you don't set the path, the default name will be used. If you want to create multiple secret engines of the same type, say of AWS, and say you have 10 AWS accounts and you want to create API keys for each one, what you can do is create a secret engine with a separate path that addresses each one of those accounts. And you reference that in the config here, in the path, right? So you can create multiples of those secret engines of the same type. There's no limit there. KV we'll quickly cover. So I'll always suggest using KV version 2, which allows you to support versioning. You can roll back to previous versions of key value stores. And when you're in dev mode, it's automatically enabled for you, but in production, you must enable it explicitly. Here's some commands using the KV. I'm not going to go through those here. You will experience them in the lab. Cool. So we mentioned about the path that allows you to create multiple secret engines of the same type. And we spoke about the versioning of KV2. All right. So we spoke about the secret engines, but then there's a really important concept of you must authenticate to Vault before you access any secret, right? And how do you do that for different types of applications and supporting multi-cloud? So Vault supports many, many different types of authentication methods, as you can see. We support ones that are ideal for like on-prem, which we'll go through, and some are really, really useful for cloud. For example, EC2 instance role you could use to authenticate to Vault. And similar to the other cloud providers, you can use Okta, LDAP, and so on. Kubernetes service accounts, you can also use to authenticate to Vault to fetch secrets. We can split them into two different categories, right? We've got the methods that are more aligned to users and methods that are more aligned to applications. So for example, SAML login, LDAP, Okta, they're more focused on the user. On the application side, you've got things like Kubernetes, the AWS, the cloud IAM, and the app role is another option for on-prem workloads. Very similar to the secret engine, there's a Vault auth enable, and then you put the type of authentication method. In this case, it's AWS, but also you can set paths. Once again, you can create multiple instances of that authentication method for different environments, for whatever your requirement may be, but you can configure multiple of those same authentication methods. The user path authentication method is a quick way of getting started. You will use that in the lab where you're creating local username and password in Vault and not tied to LDAP or anything like that. And yeah, it's a really quick way of getting started. Yeah, so what type of entities? We authenticate users and applications, right? And the user path method is only stored on Vault, and you have to explicitly assign a policy to give access to a client, to an entity to access a secret. So by default, it's all not allowed, and which finally brings us to Vault policies. This will be the last chapter for the introduction before we jump into our first lab. So cool. So Vault policies restrict the secrets and users and applications have access to. Pretty obvious. By default, it's deny everything, right? And you have to explicitly allow or grant user or an application access to a path which contains the secrets. It's path-based and it's written in HashiCorp configuration language. Here is a quick example. So tokens have the ability to look up their properties on themselves. Based on the capabilities, we're allowing whichever token that has this policy attached to it, we're giving it the permission to look up its own properties. However, if we take that off, they will not be able to do anything. They will not be able to look up their properties. And they cannot make changes because we haven't done any other capabilities. There are 5 types of capabilities. So create, read, update, delete, and list. Okay, so quite self-explanatory. And they all kind of correspond to API calls like with post and get. And the API documentation is well updated. You can use that for a reference. Sudo is an important, there is a capability for sudo. So some paths require privileged access. So you must have the sudo capability assigned to that. And obviously deny is an explicit deny that you can put. Here's an example of a policy for a line of business. Say, for example, you have a line of business A, department 1 within that line of business, and they have secrets, anything that's passed in that path. The capabilities give them access to pretty much everything. So read, list, create, delete, update. Now, any user or any application that has access to this policy is able to make modifications for any secret that's beyond this path and nothing else. And again, you'll go through that in the lab. You will have the opportunity to configure a policy in the lab, so I won't spend too much time in here, but it's basically Vault policy write, the name of the policy, and the file containing the policy, like HCL file. Once you've created the policy, then you assign it to a user or an application. In this case, Joe, we're updating the policies to this policy we've just updated. Cool. So as a recap, basically, Vault does not grant any access for any secret by default. It's an implicit deny. You have the corresponding capabilities are create, read, update, delete, and list. And also the way you write the CLI, writing a policy is Vault policy write. Now, cool. So we're up to the exciting part where you get to go through the labs. So the first lab will be the Vaultbasics lab, and it's on the Instruct platform. We will be sent through to our break rooms shortly, but I just wanted to show you what that screen should look like. It should look something like this. Is what you should see. You should see these tracks, and the first track we are going to do is the Vaultbasics. So if you click on that, you start the track, and as you can see, there are 7 challenges, and you just go through each one. It's self-paced. You will get 30 minutes to complete this section, right? And we will be there in the room with you. So if you have any questions, feel free to ask, and we'll guide you along the way. All right. So I hope everyone can see, has access to the Instruct now, and we'll go from there. Hello, everyone. Hopefully you've enjoyed your break. We can kickstart again the second session. So we'll do a quick review of what we've done in the first lab. It'll be very brief, and then we can get ready to move into the second section of the lab. So with that in mind, you've covered quite a lot of ground so far in the introduction lab. So we'll just recap. We were able to launch a Vault server in dev mode. So that's great. So now you have an idea on how to do that. The other thing, the other challenge you did was how to call the HTTP API using your curl statements. And you were able to create your very first secret. Then we've also, based on a configuration file, we've launched a Vault production server, right? And then we've enabled the KV2 secret engine via the CLI. And then we've created, or we've enabled or mounted the user auth method, sorry. And then we've enabled some policies to show how you control access, one user having access to their secrets while the other being denied. So hopefully you've got a lot out of that. Certainly you can revisit it. The labs will be made available after this for you to kind of revisit and have a look through again. Cool. So with that in mind, we've got quite a bit to cover around the dynamic secrets side of things. So we've covered a lot around the static secrets with the KV. And what about dynamic secrets? We'll focus on database secret engine. It is widely utilized in a lot of enterprises using Vault today. So it's beneficial for us to go through it and give you a view of what that looks like. So protecting databases. So database credentials typically are long-lived, right? You've seen it way too many times where you create local usernames and passwords on the database system itself, and then you kind of hand them out to an application or to an administrator, and they're long-lived. But they do not get rotated very regularly, and this is where the dynamic secret engine for Vault comes in, where you're able to dynamically generate short-lived credentials based on a time to live that you specify. So you have full control on the life cycle. You're able to revoke, rotate, and safely share those credentials with who needs it, once they've authenticated, of course. It supports configurations of database connections and roles with different permissions and different times to live. So it's very flexible of how do you build authorization models, like what tables they can access, what the time to live that you set on it. And the way you do that is you specify in a role all these parameters. So all the credentials, the configurations, you assign them to a role, and then the role, if you have the permission to use that role to generate the credentials, the parameters in that role dictate what is allowed, right? The time to live, the SQL statement that's used to create the user, and so on. The Vault manages the life cycle of these credentials, and they automatically get deleted. So when the time to live reaches, say you set it for for 10 minutes for an administrator to complete their task, or for a batch job, you can leave it, for example, running the credentials for a day. You could do that, and Vault will automatically remove those credentials once it's done. All right. The plugins we support for the database secret engine are many. So as you can see, this is a list, and Couchbase is not there. So we're continuously adding to this, and it's growing continuously. I can be almost certain that you would be running one of these databases in your environment, and the question about credentials and how do we make it accessible for administrator, or not for administrator, but for applications, for scripts. How do we enable that and provide short-lived secrets? This is definitely one way of going about it. So how do we set it up? The secret engine workflow is actually quite straightforward. So you've enabled the KV secret engine, for example. You would use the same to mount the database secret engine. So it'll be of type database. And then you have to choose the correct plugin that corresponds with the database, the target database you wish to connect into, for Vault to connect to. Then you create one or more roles with specific TTLs and the SQL statements with the permissions that you wish to provide, right? And we'll go through an example of that shortly. And then the application can request a credential from Vault. So once they authenticate, they call on that role. The role will create the credentials on behalf of the application and return back the username and password for that database with that time to live. And then once the Vault will automatically delete the expired credentials once the TTL. Now, a question we get asked is, well, can we refresh or can we renew the lease on those credentials? And the answer is yes. So you can renew them. So for example, you can set the maximum TTL to be, say, 3 months, but every day you must check in to renew the lease. And when the lease is not renewed, that's a sign that the application is no longer requiring those credentials, and then Vault will actually remove them. And obviously, if the credentials are compromised, you can revoke them immediately. We are going to, the next lab environment is managing the database secret engine, connecting to a MySQL database. So and we're going to have a Python web application that stores data in a MySQL database. This will be introduced in the next lab. So we've got 2 labs that work with databases, and we'll cover some of the configurations that you'll need to, take into account. We've already covered the steps here, but just to quickly recap: so you enable the secret engine, you specify the plugin with the connection URL, the username and password. So you typically create a service account for Vault to have permissions to connect to the database, right? And those permissions will allow Vault to create users and remove users, create credentials and remove credentials. Vault also has the ability to rotate the service account credentials that are given to Vault. So no longer is a human able to keep track of that password. And I'll re-emphasize that a bit later. When you create the roles, they create the roles that can create the new credentials are valid for a specific period of time. So that's with the TTL. Here's an example of how to set up the secret engine. As you can see here, the Vault Secrets enable. We're setting the path. As you can see, the path is very flexible. So you can set it to, to represent a line of business, a project. It's really up to you. And it's of type database. And once we mount the secret engine, we then need to configure it. And we do that by doing a Vault write. And if you have a look at, we use the path that was used here. And we're going to the config endpoint and we're configuring it with these details. So the plugin name is MySQL Database Plugin. Here's the connection URL. So you have a username, password at TCP, and that would be the IP address of the SQL server. The allowed roles, we haven't created the roles yet, but these are the allowed roles. Once a user authenticates, they can use to access this database secret engine. This is the Vault username, the Vault service account on the database. So its username is HashiCorp in this example, and the password is password123. Now, as an administrator, I would have written that down. The Vault can actually rotate this password, and only Vault will know that password from then on. All right. There's a couple of things in terms of rotating the root credentials. So as you can see, probably this is the main point I want to highlight. Typically, when you provision a database, you have like a root username and password, which has full privilege, right? Now, we're not saying, like, we do not recommend that you use those credentials to put into Vault as the service account. You create another set of credentials for Vault, and you use the original root user and password as a break glass. So just in case you need to regain access to the database, you have those safely locked away, right? And you let Vault use a separate user with sufficient privileges to manage the users. And this is the key point I wanted to highlight here. Now, once we've configured the backend or the secret engine, we now need to configure the roles. So if you recall, one of the roles that is allowed to use that secret engine was the workshop app long. And if you notice, it's using the same path, roles, and this is the role name. It's using that same database reference that we've done in the previous configuration. And here is the creation statement. This is where this role will create, once you initiate it or use it, it will use this create statement to create a user in the database. And if you have a look, these are the permissions. Grant all on my app.star. So this is saying grant all permissions only on this database and the tables within that database. What that means is if there's any other tables or any other databases in that database, this role will not give permission to access any other database other than my app. So this is something to note where you can now create like an authorization model also. It's not just authentication, but you can authorize users who use this role what they can access. And this is very important. The default TTL, 1 hour, and the max TTL is 24 hours. So you must renew within an hour every time. You must request an extension on the lease if you want to maintain the same username and password. And you have a maximum of 24 hours to maintain that. Once the maximum TTL is done, Vault will revoke the username and password, and the application will need to request a new set of credentials. That's what that means. So how do we go about generating the database credentials now? So we've covered the secret engine, we've covered the configuration and the connection string and the role. Now, how do we use the role to generate the credentials? And it's a Vault read command. And if you notice, it's using the creds path and the role name. And if you have permission to access this path, this is a sample output you would get. You would get a username and you would get a password with a time to live. And these would be configured on the database and passed back to the application or whoever called this endpoint. Now, what can I do once I've got the secret and I've created the lease? You can actually renew the lease. So you can provide the lease ID. As you can see, this would be the lease ID, and you can renew it, and you can extend it by whatever amount that's available to you. You can extend by 5 minutes, 1 hour, whatever that's the limit of the TTL allows you, right? You can also revoke, and this is the endpoint for revoke. So you do sys leases revoke, and you put the lease ID. It removes the credentials out from the database. And you can also do a lookup to see, for example, how much lifetime is left in that lease. Does it have, a few minutes left, a day left? You can see all that information in the lease. And you'll go through all this in the lab exercise shortly. So saying that, you should see now, as part of the Instruct Lab environments, you should see the Vault Dynamic Database Credentials track. So if you want to go to that and make a start, so let me get out of that. Sorry, I'm showing all the tracks. Sorry, you should be able to see in your track. And once you go into that, just click on the start and you should be able to continue with that. So with that, I think we can go into our breakout rooms. Hopefully you got to go through the full lab. There was a lot to cover there, but hopefully you see how powerful it can be for you to be able to dynamically generate these secrets on demand, right? And be able to control the life cycle. So the implications here, for microservices, new applications, is quite compelling. You have full control of that and making it very easy for developers as they develop their applications to speed up that development lifecycle without having to bother the database team or things like that, right? So just wanted to quickly recap the challenges, and then we'll go to the last section of what we need to cover today. So we did the enabling of the engine. That was quite straightforward. And after we've enabled the secret engine, we configured it with the roles and with the 2 roles with the different TTLs, right? And the configurations for the creation of the user, what are they authorized to do on the database. And then we've gone through the creation of the credentials and how to do that via API, via the CLI, and also how to renew and revoke those credentials. And these concepts are applicable for across many of our secret engines, right? So AWS credentials, for example, API keys, the cloud API keys, same process, right? You get a time to live, you generate on-demand credentials with a time to live for the application to do what it needs to do, and then these credentials are revoked. So this is not just specific to databases, but it gives you a general flow for the majority of the secret engines we have. Cool. So what is the primary advantage of a database secret engine, right? They provide short-lived credentials and are less likely to be compromised. And if there is a compromise, from the monitoring, you can exactly see it came from which application, from at what time, because there is everything's auditable. There's a full audit trail that you can create from Vault. Also, you can, what happens when the credentials expire? They are deleted basically from the database server. Pretty straightforward. Is the database engine limited to the plugins listed in this chapter? No. So custom plugins can also be written. So you may have custom infrastructure or applications you wish to enable this for. You can create your own plugins. And can more than one role be used for a single connection? The answer is yes. So we've demonstrated 2 roles with 2 different times to lives that were targeting the same database as an example. Cool. So we've covered a major section there. This will be the last chapter, which we will cover encryption as a service. Now, The Vault Transit engine is the secret engine that enables this. Now, why do we need to look at encryption as a service? So a lot of for us to better protect data, for enterprises to better protect their data, client-side encryption is becoming a lot more prevalent. We need to encrypt the data so wherever it gets stored, we know it is secured, right? And only authorized applications or people that can decrypt that data. Vault enables this by providing a very simple API that applications can use to both encrypt and decrypt their data. So you can create the Vault encryption as a service hosts the encryption keys locally on Vault. They never leave the Vault. You provide a role for the application and the permissions for it to encrypt. So it will send the clear text to the Vault. Vault will encrypt it and send back the encrypted text, right? And then the application can write it into the database as an example, right? And the reverse is applicable. So if the application needs to decrypt the data to present to an end user, then basically the reverse happens. The application retrieves the ciphertext from the database, sends it to Vault, Vault decrypts it, sends it back to the application, then it is presented. The biggest advantage we see is, first of all, we're making it very easy for developers to find ways of protecting data and comply with security requirements. The other thing is developers no longer need to work out, manage the burden of all of the encryption modules. That's all done by Vault, right? And they just interact with the API. So we've spoken already about some of those benefits, but just to recap, it provides also centralized key management. Because the encryption keys never leave the Vault, you have assurance that the life cycle, everything, who has access to the keys, you fully manage with Vault policies. And only approved ciphers and algorithms are used. We support many different types of algorithms and ciphers. And you have the ability to do key rotations and rewrapping of the data to use the newer encryption keys. Like say you do a rotation, you can rewrap it. And even if the attacker manages to get access to the encrypted data, they'll only see ciphertext, right? And because you're doing constant rotations, also you're using new keys, that also improves the security of your data. We're going to go through an example application. So we have in the next lab, we have a web application that will use the transit secret engine to encrypt and decrypt. And it will actually use the same database that we've done in the previous example. So the MySQL database, where this application will go and fetch dynamic credentials from Vault using the roles we've created, right? And then it will use the transit secret engine to encrypt the data and write it into the database, right? So we'll go through that and you'll see how it is done. The web application is quite simple. It will give you the ability to, this is a screenshot, it'll provide you the ability to update and like add records. And you get two views. You get a database view and you get like the records view, like to the end user. So you'll see the difference there. The records view displays like the records in plain text, like for an end user. And so the application would need to request Vault to decrypt the data before it gets presented. Now, the database view is what you'll see the data encrypted at rest. And you'll see ciphertext come back. So this is what would be the records view, pretty straightforward. And you'll see the database view shortly. Now, yeah, it's a simple, just you can add as many records as you want, up to you. So have a play with the app, see how it works. You're going to go through two steps. The first thing you're going to do is run it without Vault enabled, the application. So you're going to have everything in clear text basically stored in the database. And you'll see that the PII data, right, is easily viewable. So if somebody wants to log into the database, run a query, they'll see all this data. And then we're going to find a way of how do we improve this. So with the transit secret engine, we're going to enable the capability to encrypt. And then you'll start to see the encrypted data. So the database results, you start to see things like this, ciphertext, right? And you'll see how that works under the hood when you go through the lab. Then you're going to go through a rotation of this, like the encryption key. How do you go about rotating and rewrapping? Like using a newer version of the encryption key. You'll go through that exercise in the lab. And that's it. From a theory perspective, that's all it is in regards to the transit secret engine, the benefits and why to use it. So we're going to switch over to the lab, and just wanted to switch the share. All right, here we go again. I think I've gone into the same issue here. Vault, this one, Vault encryption as a service. So you should see this track available for you, and you can go into that track. There's 4 challenges in there, and you'll go through the steps, quite straightforward, and we'll give you a good view. This session should take about, we estimate 30 minutes, and this will be the last lab. So if we can go into our breakout rooms, that would be fantastic. Hopefully you found that useful, and let me just share my screen. Cool. So we've covered quite a bit around data protection using, transit secret engine. So just as a way of review, we've shown the ability to be able to rotate the encryption keys, better protect our data by offloading the encryption decryption to Vault, and safely securing this data in the database. I guess with that in mind, that we've reached the conclusion of the workshop. Just wanted to reiterate that the workshop, the labs will be made available for a few more days for you to revisit. Some more communications will come out about that. Otherwise, and you do have access to the slides. These are publicly available, so you can go back to them at any time you wish. And I wish to thank you for your contribution. There's been some really good questions. Hopefully you got a lot of use out of this. And yeah, this is, hopefully this will help you in securing your environments a little bit better, or much better.